Now do electric circuits E number 3. And in this problem, we have a power supply, which is represented by the box here. This is the power supply for this problem. The darker boxes over in the circuits, over here, those are represented as resistors. As you can see, the 10 ohm resistance in that darker box. This darker box down below it, down here, actually doesn't have a resistance. You're going to need to fill that in. Now, any meters which are represented by circles that are in parallel with the resistance, those will be voltmeters. And any meters, such as the one over here, that are in series with the resistors, those are going to be ammeters, which measure current. So in this case, we need to fill in our meters and missing resistance. And we're going to use a lot of Ohm's law. Remember, V equals IR. So to solve this equation, we need 2 of the 3 variables. And we can also use the fact that resistors in parallel have the exact same voltage. So notice we have 8 volts on this resistor, which is in parallel with the resistor above it. So this meter up here must also be 8.0 volts. Now what we want to do is we can start filling in some of the other missing boxes where we have 2 knowns. So for this resistor here, I'm going to use V equals IR. And I'm going to solve for R using R is equal to V over I, which for that resistor, the voltage is going to be 8.00 volts divided by my current of 0.160 amps. And that resistance is going to end up being 50 ohms. So I'm going to put my 50 ohms in there. Now, that gives me that resistor. Next thing I can do is I can go up and I can get that ammeter right there, because I know, once again, V equals IR, or I equals V over R, which the current going through that meter is going to be the exact same current going through the 10 ohm resistor right here. So my voltage is 8.00 volts divided by 10.0 ohms. So my current is 0.8 amps. There's another 0 in there, sig figs. I just didn't want to write it, get it on there. So let's go 0.800 amps to fill in that one. Now this out here, this meter right there, that's another ammeter. It's in the circuit, it's not parallel to it. And for that one, what we have here is we have a current coming in this side of 0.16 amps. We have a current coming in this side of 0.80 amps. So the total current in the circuit, whatever comes into this point, must equal what's going through that ammeter. So the current there is going to be 0.160 amps plus 0.800 amps, or this is going to be equal to 0.960 amps. So 0.96 amps. So we have one more meter to fill in. And notice that's in parallel with the entire circuit. It doesn't break the circuit, it's in parallel with it. This is the voltage being supplied by the power supply. Notice that this voltage is literally in parallel with the 2 resistors. So whatever voltage is across each resistor must also be, since it's in parallel, must also be equal to the circuit voltage. And that now fills in all the meters for this one.